many other examples about the nano size in nature. The first most common example of nano size or nanoparticle, that is a lotus effect. Okay. So what is lotus effect? So lotus leaves, you know that it is highly hydrophobic, or we can say it is a superphobic property it is having. So the hydrophobic structure of a lotus leaf that governs the lotus effect. The high contact angle creates a rolling effect of the water droplets supported by the micro protrusions. Okay, that is a microscale epidermal cells. The nanoscale wax crystals. So that was they have the researchers have worked on that, and they have took the same image of that is scanning electron microscope image of the leaf of the lotus, and they found that the nanoscale wax crystals facilitate the water droplet to remain buoyant, roll down and collect the debris before descending from the leaf. Okay, so that is a very important phenomena that was observed by the scientists, and you will be surprised to know that this has been long back, it has been reported in the Bhagavad Gita in the chapter 5, and that was well studied by the researcher, and they found that in the image of what we can see in the scanning electron microscope, that the natural terrain, these are the terrain consisting of hills, and we can see the valleys. The valleys exist between the hills, and which can be eluded to form the earlier discussed microscopic structure. So they have the microscopic structure, you can see 3.8 micrometer, and that's what the water droplets cannot reach the valley. So when the water falls on the leaves, it cannot reach the valley due to their larger size. So that is the lotus effect. We can see this. It will not fall down, so it will not reach the valley, but it will just roll around that, and it will remove the debris, and that's what the lotus effect. That was the example that is found in the nature. Okay. Similarly, we have the one more example, and that is the gecko effect. What is a gecko effect? So, gecko is nothing but it's actually a lizard. Okay. So gecko effect that can hold on to any surface at any orientation. It can run on smooth or rough surfaces, even upside down on a glass surface. Okay. So this is based on the nanotechnology. It can attach and detach their toes. So these are the toes what we can see in the image, and they have the milliseconds to nearly every material. Okay. So gecko can run on a dirty or wet surface, maintaining full contact and addition to it. That the gecko's amazing properties lies in the nanostructures that are present on its feet. So these are all the nanostructures what we can see on the gecko's leg. So there are many other examples of nanotechnology, that is biomimetics. Okay. So what is biomimetics? So basically the field of material engineering that is devoted to trying to fabricate artificial material that mimic natural one, and there are n number of examples that we can see that have this type of phenomena. So basically the eels and the nervous system. So these we can see they have the electrical conduction, and the deep sea fish and the glowworms, they have the photo emission phenomena, and these are all the having the nano particle size. The butterfly and the butterwings, they have the photonic crystals. So these again they have the nano sizes. Lotus leaf just now we have seen in detail, and the human skin, again human skin, that is they have the hydrophobic surfaces. Then gecko's feet, that also we have seen in the earlier slide, they have the adhesives, and because of this adhesives they can stick to the wall, they can stick to the glass surfaces. Then even the spider silk, they have the high tensile strength and fiber because of their nano feeds. Then human brain, again it is a very nano size because of the neurons, that is a neurotransmitters they have. They can transmit from, they can pass one signal to other, and that is because of the artificial it gives rise to the latest technology, artificial intelligence and computing. So these are various examples we can see, and the most recent one, that is a carbon nanotube, that is CNT. So carbon nanotube is nothing but it is made up of enrolled cylindrical graphite. So these are the cylindrical graphite sheets, and it is named as a graphene, wrapped up into a seamless cylindrical with a nano size diameter. So this is it is having a 1 nanometer diameter. They are electrically and thermally conducive and have a high mechanical strength. Parallel arrays of multi-wall carbon nanotubes. So these are it is having a parallel shapes, and they have it gives rise to the array and can drawn into electrically conducive continuous length web. They are utilized in energy storage, device modeling, automotive parts, boat hulls, sport goods, water filters, thin film electronics, coatings, actuators, and electronic shields. So there are n number of applications of the carbon nanotubes, and not restricted to that field, but it has various medical field as well. So there are various other shapes that can lead to nanocrystals, that is using noble metals, and you can see very fanciful structures you can see that has been generated by various researchers in from different countries. So when we talk about the noble metals, so these are the noble metals like copper, silver, gold, platinum, rhodium. So the metal plays a very important role in providing a different shape, and that is what the researcher has worked. So it should be pointed out that the presence of the capping agent. So capping agent is nothing but the agent that holds the metal and that gives rise to a different nanocrystals. Can also significantly affect the internal structure of the product, and in addition to the surface structure, one compiling example can be found in the synthesis of palladium nanocrystals. So shape, but we can have various shapes, and that is what the researcher has worked. So when a palladium precursor was reduced by ascorbic acid, for example, we get a single crystal palladium nanocrystal. So this is a single crystal